Okay, we're going to work on some trigonometric integration problems, and these are going to involve powers of secant. Specifically, we're going to look at the even power of secant. So let's look at an example and the process of what we need to do to integrate when we have even powers of secant. So if I have secant squared tangent x dx. So again, notice here that my power here is even. So I have an even power of secant. I'm going to ignore the power here for tangent. You're going to see why. And we're going to go with this approach. We're going to let here, we're going to let u be tangent. And when we let u be tangent, we'll get du being secant squared dx, because the derivative of tangent is secant squared. So we're essentially going to perform a u substitution here. So now my integral will be secant squared x, u is my tangent, and I have dx. So performing u sub, we could look at this a couple of ways. I can say that dx will be, solving this here for dx, dx will be du over secant squared x, so that I can replace this dx with du over secant squared x. So my integration now becomes secant squared times u times du here over secant squared x. Secant squareds cancel, and we end up with the integral of u du. And so this becomes 1/2 u squared plus c. And if we go back and remember what u is here, well, u is tangent. So my final answer here is going to be 1/2 tangent squared x plus c. So this is how we're going to approach when we have an even power here for secant. Let's look at another example here. If we say we have secant squared x tangent squared x dx, we notice we have an even power here for secant. Now going with the exact same approach, we let u be tangent, that gives you du being secant squared x dx, because we're going to differentiate u with respect to x. Now, I'm going to approach this integration a little bit different. Again, we're going to do u sub here. So this is u substitution. But I want to point out here to you that if I rearrange my terms, then I have tangent squared x times secant squared x dx. When I do my u sub, I'm going to replace tangent with u, and I'm also going to replace this portion here, secant squared dx is the same secant squared dx. I get to replace this now with du, because this is what du is actually equal to. So this portion down here is going to be my du. So then your integral is going to become u squared du. This is similar to what we did over here. However, I solved for dx in my u sub, and I had my cancellation here with that secant squared. So it's pretty much the same kind of thing. There's different approaches here, so I'm showing you both approaches, and you could decide what you'd like to use. And so this integral now becomes 1/3 u to the third plus c, where again my u here is tangent. So final answer, 1/3 tangent cubed x plus c. Okay, so here's another example of when you have an even power of secant. Let's look at this next question here. What if they gave us, and this was secant squared tangent squared, what if we had secant to the fourth power of x tangent squared x dx? Now, the process is the same, however, we're going to notice something here. Remember, we're going to let u be tangent. And by doing so, my du becomes secant squared x dx. Now, I don't have a secant squared here. I have my fourth power here, which is a nice even power, so we're going to go with this approach where u is going to be tangent and du is secant squared dx. But I don't have a secant squared here. So let's consider here the fact that we're going to note that I have secant squared tangent squared x here for my integrand. So this whole thing, I'll put that in gray. I'm going to factor out a power of secant squared. So we're going to notate this. So at this point, factor out a secant squared x from this function here. This is factoring out that secant squared. And so now when I let my u be tangent, I will have du being secant squared. I also need to use an identity here. So I'm going to emphasize another sort of aspect here, and I got to change this color. Let's change it to blue here. I have an extra secant squared factor. Now what I'm going to use with this extra secant squared factor, I'll write it in blue, is I'm going to remember that secant squared by the Pythagorean identity is 1 plus tangent squared. So altogether, here's what I have here. Let's put this together. I have secant squared x, that factor I factored out, 1 plus tangent squared x for the extra secant squared we have right here. And I'm going to leave this as tangent squared x here. So here's really the important details of what we need to do. We're going to let u be tangent. That means du is secant squared x dx. I'm going to factor out a secant squared, and I'm going to use my Pythagorean identity for secant squared. This is what the integral becomes now. Secant squared x, 1 plus tangent squared x dx. So don't forget what u is. U is tangent, so here's a tangent, here's a tangent, but they are squared. And if I do a little bit of rearranging the terms here, I got 1 plus u squared times u squared here for these terms. And then notice, if I rearrange this, I'll have secant squared dx. However, secant squared dx is going to be my du here. So we get to replace this with a du. So this gets replaced with du. Now, I have 1 plus u squared du. And here's where I'm going to use the distributive property. I'm going to distribute now. So I'll get the integral of u squared plus u to the fourth du by distributing here. And when I integrate, I'll have 1/3 u to the third plus 1/5 u to the fifth plus c. Now let's go back and determine what u is again. U is going to be here. Let's go back here. My tangent. So final answer, 1/3 tangent cubed x plus 1/5 tangent to the fifth x plus that c. And there you go. So that's the procedure we're going to essentially use here. And we can move on to another. Let's try this here. Let's try a secant to the 6th power x times maybe tangent cube x dx. Now, I'm going to summarize this procedure here, and this is what this summary really becomes again. You're going to let u be tangent. We're going to factor out a secant squared term, and we're going to use the Pythagorean identity that secant squared is 1 plus tangent squared. And yes, if u was tangent, du would be secant squared x dx. This is all I need to do my u substitution here. Notice again, even power for secant. Okay, so let's focus on the function here. So we have secant squared times secant to the 4th power x times tangent to the 3rd power of x. Here's the factoring out portion of secant squared. This secant to the 4th gets replaced with secant squared to the 2nd power. I got tangent, let's go back. We got tangent to the 3rd power and if u is tangent, this portion really becomes u to the 3rd power. And don't forget, I now have to replace secant squared with 1 plus tangent squared x. Okay, let's actually write this over again. Secant squared 1 plus tangent squared squared u to the 3rd power. Now again, our u is tangent. So replacing u with tangent, algebraically we get secant squared 1 plus u squared in parentheses squared u cubed. So this integral now is what we're going to integrate. There's a dx here. And let's go back and use this fact that du is secant squared x dx. So here's my secant squared and here's my dx. I can replace this product with simply du. So I have the integral of 1 plus u squared squared u to the 3rd du. So this is the process that we use, and now you can see here that there's some algebra to perform, because this portion here is 1 plus u squared times 1 plus u squared, u to the third power here. This portion here becomes a nice FOIL. And by FOIL you get 1 plus 2u squared plus u to the fourth when multiply this by u third. Let's not forget to distribute here. U to the third plus 2u to the fifth plus u to the seventh. We're going to integrate this du. So I'll end up with 1/4 u to the fourth plus 2/6 u to the sixth plus 1/8 u to the eighth plus that c. So I get 1/4 u to the fourth plus 1/3 u to the sixth plus 1/8 u to the eighth plus c. Now u again, remember, is tangent right up here. So we're going to replace u with our tangent in our final answer. 1/4 tangent to the fourth power x plus 1/3 tangent to the sixth power of x plus 1/8 tangent to the eighth power x plus c. And here's the answer here. So again, here's an even power. And this is the process that we'd use when we have even powers of, looks like secant. Now let's note, you might say, what about odd powers of secant? Well, let's consider the first odd power of secant here. Something that looks like this. We can integrate secant x dx. Now, we did this in class, and remember, it's a very famous, or I should say, this derivation, people very often, it blows their mind. Because you have to pull a rabbit out of the hat, meaning what you're going to do here is you're going to multiply the numerator by the sum of secant and tangent. And the denominator here. So what you end up algebraically is secant squared x plus secant tangent over secant plus tangent. So this is what's going to have for our integration. Now we're going to use u sub. When you use u sub, you get u, you're going to let u be the sum of secant plus tangent. Automatically that gives you du, which is derivative of secant is secant tangent. And then derivative of tangent is secant squared. And that's a dx. So what you're going to notice here is this bottom portion, let's color it maybe blue here. This is my u. So I replace this with u. And let's use the purple here to notice that secant squared plus secant tangent dx is what you see right here. That's going to be my du. So I'm going to replace this whole thing with a du. We now get the integral of 1 over u du, which is the natural log absolute value of u plus c. So we have natural log absolute value of secant plus tangent plus c. And here's our final answer. So let's write this in black here again. Natural log absolute value of secant plus tangent plus c. So here's our first odd power here. Now, if we generate another odd power, and this is kind of what I start to talk about with odd powers in class here, we can generate now, go to the next example here. You want to integrate maybe secant cubed x dx. Now, this is another integral we have to know. And let me show you how you go about this particular problem. We're going to look at the product here of secant times secant squared. So this integral really is going to become the integral of secant times secant squared dx. Now how we integrate secant cubed here is we're going to use integration by parts. For integration by parts here, we're going to let u be, so let's change this here. This is going to be my u, and this whole thing will be my dv. So that u becomes secant x, and dv will be secant squared x dx by integration by parts. Now, if I have u, I need du, so the derivative of secant is secant tangent. If dv is secant squared, then that means v is the integral of secant squared dx, which means v is actually tangent, because the derivative of tangent is secant squared. So I have all the information I need here. I have u, I have du, I have dv, and I also have v. Because for integration by parts, remember what that is. It's a formula. It is uv minus the integral of v du. So let's put this together now. uv is going to be secant tangent minus the integral of tangent, where du is secant tangent dx. Let's not forget there's a dx here. Okay? And so, doing a little bit of algebra, we get secant tangent minus the integral of secant tangent squared x dx. Now, notice here what we should do. It looks like what we can do here now is replace our tangent squared with the Pythagorean identity secant squared minus 1, because tangent squared is secant squared minus 1. So this integral now becomes, let me bring everything down with it. We get secant tangent minus the integral of secant squared x minus 1 dx. So doing some algebra now, we get secant cubed x minus secant x dx. And so by properties of integration here, we get secant tangent minus the integral of secant cubed x dx plus the integral of secant x dx. Now let's notice something here. This problem was secant cubed x dx from the beginning here. And so sometimes I should say to people, well, what you notice is that we have the original question and we have here the same question, meaning we're trying to integrate secant cubed. There is a minus sign here. Now that's a nice thing, because what happens here is I could now add to both sides. And we don't really have two sides here. But what I'm adding to both sides is the integral of secant cube x dx. So it doesn't look very appropriate. Or how about if I say to you, it might be better for us to do this. We can translate, we can move this integral to the other side of my equal sign. Point being, you end up with 2 times the integral of secant cube x dx equal to secant tangent minus the integral of secant dx. So we know the integral of secant. This is the natural log absolute value of secant plus tangent. Don't forget to add your constant. And so altogether, twice the integral of secant cube x dx became secant tangent minus the natural log absolute value of secant plus tangent. How about if I just go back and do this? Let's just tell you guys, why don't you divide both sides? And I'll put it here in red. Divide both sides by 2. This side by 2, and this whole other side by 2. Okay, we're running out of space here. That means that this integral of secant cube dx now becomes 1/2 secant times tangent minus the natural log of secant plus tangent. And don't forget to add your constant. In other words, we'll write it now this way. 1/2 secant tangent minus the natural log absolute value of secant plus tangent plus that c. And this is how we go about doing some fundamental integration for the various powers of secant. Now, let's do a couple of more examples here just to kind of go back for a quick second here for you. Okay, we're going to continue with some u sub versions of our integration of secant. You can have the integral of secant pi x dx. Now notice here, we have pi x, not x, so that's going to mean we use u sub. So by u substitution here, we're going to let u be pi x. If u is pi x, that means du is pi dx, or it means dx becomes du over pi. And so you're going to integrate here secant u du over pi, where we're going to pull out our constant by properties of integration. Now we got 1 over pi, the integral of secant u du. Here, we're going to use a formula for secant. Now the formula for secant, if you guys remember, we already actually determined here. That formula we found, that was one of the first odd power integration, here we go, formulas we're going to use here. Here it is. Okay. So notice here, this is the integral of secant x, but we're going to change this x to u. And now we can use this formula. It's the natural log secant u plus tangent u in absolute value. So let's use that. So this is a handy formula to know. It shows up a lot. I got to replace this with natural log absolute value secant u plus tangent u plus that constant c. So altogether, I have 1 over pi natural log absolute value of secant u plus tangent u plus our constant c. Now remember, u here is pi x. So I'm going to go back now. Let's do that in red maybe. I'm going to go back and fill in pi x here for my u. So as a final answer, we'll have 1 over pi natural log absolute value of secant of pi x plus tangent of pi x plus that constant c. So here is the integral of secant pi x, and notice we did use substitution. The key here though is to always remember this particular formula. It'll save you some time here, how to integrate secant. Now similarly, we can have an integral using u sub that maybe is secant cube. Now we're going to say that this is going to be x over 4 dx. So this is another odd power secant we looked at, and then notice we have x over 4 here. So we're going to use u sub. By u sub, u becomes x over 4, and then du is 1/4 dx, which means my dx is 4 du. So we integrate here, secant cube, this will be u now, and now I have 4 du. We're going to factor out that 4 by properties of integrals, bring it outside my integral sign, and now I'm left with the idea here that I have to have or know the integral of secant cube. Now we did integrate secant cube here. Go back, and we have a formula here. Okay, here's our integral of secant cube. All right, this is the original question of secant cube. Now we integrated, and we have here, let's take a look. We have this formula. Okay, so here's another handy formula to know. But this time, remember what we're going to do with that x here. That's now going to be u. And so wherever there's an x, we replace that with a u, and we're going to use this formula. So it's 1/2 secant u tangent u minus the natural log secant u plus tangent u in absolute value. So I'm going to replace this integral here with 1/2 secant u tangent u plus the natural log absolute value of secant u plus tangent u plus my c. Now remember, there's a 4 out here. That 4. So we're going to multiply this whole thing by 4. And we also know that u is x over 4. So wherever there's a u, right, here there's a u, a u, a u, and a u. We replace this with x over 4. So that'll have an x over 4. X over 4. All my u's have x over formula. It's a formula now. And so my final answer, we'll write this way. We'll try to fit it in. 4 times 2 is really going to be 2 times secant x over 4 tangent x over 4 plus, we'll put it down here, natural log absolute value of secant x over 4 plus tangent of x over 4 plus that constant. So sometimes they don't fit as nice as we'd like. Anyway, here's how this problem would look. Now, similarly, they can say to us, we want you to integrate cosecant maybe 2 pi x dx. So we're going to have to integrate cosecant 2 pi x. Notice again, you don't have x here, we have 2 pi x, so that means we're going to have to use u substitution, where u now will be 2 pi x, and our du will be 2 pi dx, or dx becomes du over 2 pi. So my integral here will be cosecant of u. Dx becomes du over 2 pi. Now, this is my factor 2 pi. That comes out. I have 1 over 2 pi integral cosecant u du. So, we're going to have a formula for cosecant u du. So, here's what you'd have to do, maybe. I'm going to have to ask this question. What is the integral of cosecant x dx? Okay, if I know that integral, I can write a u sub version and apply it here. So we're going to have to do a quick detour and find this integral. Now, how you find this integral is very similar to how we integrated secant, but this is the integral of cosecant. This time, we're going to multiply cosecant by cosecant plus cotangent. This would be over cosecant plus cotangent here. Now notice in red, this whole fraction really is the value 1 because anything divided by itself is 1. But how this will work now is my numerator here, when I multiply, becomes cosecant squared x plus cosecant x cotangent x. This would be over cosecant x plus cotangent x. This is what we're going to integrate with respect to dx. Now notice the bottom here. We're going to use u sub. This is going to be my u. So let me go back here. Let's change this. I'm going to say this portion here is going to be my u. So by u sub, u is cosecant x plus cotangent x. That now means to find du, I have to differentiate both cosecant and cotangent. Now, du, our derivative of cosecant, is minus cosecant cotangent. And then the derivative of cotangent now is minus cosecant squared. And that's going to be my du. And don't forget there's a dx there. So if I solve for dx now, I get du over that minus cosecant. And I want to do something here to remind you. There's a negative here and a negative sign. I'm going to factor out a negative 1. So that's going to be minus now cosecant cotangent plus cosecant squared x. If we factor out that negative 1 here, the negative sign is outside here now. Now this is what we're going to use here for our du. So let's kind of go back here, or it's going to be for our dx. Now remember, this can also be done another way. Okay? We can go back up here. And some people enjoy using this version versus plugging in here. Here's this dx, right? And I think myself, because I'm on this iPad and there's no space, I would have to try to take this dx and replace this first dx here, replace it with this dx, and as you can see, there's no space. So what I might do instead is to point out to people, I'm going to erase this, or I'm going to go back and rewrite this here, that my original du, by factoring out that negative 1, I get cosecant x cotangent x plus cosecant squared x dx. So let's point out that this whole numerator, including the dx here, is really now, almost. Let's divide by -1 here. Let's get rid of this -1. We're almost done. There. Now what I want to say is this is cosecant cotangent plus cosecant squared dx. This is my equal to du over -1. So this problem is really going to come down to minus 1 over u du by u sub. And that gives me minus natural log absolute value of u plus c, or minus natural log absolute value of cosecant x plus cotangent x, because after all, my u here, this u, was what we said it was up here. So it's a very similar process for integrating secant. Now, let's note why we did this. The u sub version of this, or we should say, let's first start off with what this means. We integrate cosecant. This integral is minus natural log absolute value cosecant plus cotangent plus RC. The u sub version of this means the integral of cosecant u is minus natural log absolute value cosecant u plus cotangent u plus c. This is what we're going to use here. Okay, we're going to use this integral here. For cosecant, minus natural log absolute value cosecant u plus cotangent u, because that's what was required over here. So don't forget, we have a multiple of 1 over 2 pi now. So let's change our color and continue and say 1 over 2 pi times minus natural log cosecant of u plus cotangent of u plus this c. Because we replace this here, integral of cosecant u, with what it is, and we have the factor. And there we go. We just have to remember what is u, and I'm talking about the original u. So if we start from the beginning and remember that our original u is right here. It is 2 pi x. This is what our final answer will look like with that 2 pi x for u. I'm going to factor out that negative sign, so it's negative 1 over 2 pi. Natural log, absolute value, cosecant, 2 pi x plus cotangent, 2 pi x, plus my constant c. There you go. So this is how we integrate cosecant and use it in a u sub format. Another example of this could be, here's the final example of our u sub. They gave me cosecant. They want me to now maybe integrate x over pi dx. So I got the integral of cosecant x over pi. Let's try to see how this works again. Notice I don't have x. I have pi, x over pi. So again, by u substitution, our u becomes x over pi. And now du is simply 1 over pi dx, or the dx becomes pi du. I got this integral. Cosecant now, u pi du. I'm going to factor out the pi. pi integral cosecant u du. So here I have my integral of cosecant u du. I need to know what that is. And so we're going to go back now, and let's remember, we just found what it is. It is right back here. Okay? It's minus natural log absolute value cosecant u plus cotangent u. So I'm going to now take this pi constant, it's still there. I multiply it by minus natural log absolute value cosecant of u plus cotangent of u plus that constant c. So when I distribute now, I get minus pi natural log absolute value cosecant u plus cotangent of u plus that c. Let's not forget, what is u now? U here is x over pi. So I'm going to replace this with x over pi. Replace that with x over pi. So let's write this final answer here. Minus pi natural log absolute value of cosecant x over pi plus cotangent x over pi plus that c. So here is how we're going to use u sub with trig integrals involving secant and cosecant.